Hello, boys of class 6. Welcome you to the online class of science. Already we have finished our third term syllabus. So today we will gonna start a revision from third term syllabus chapter 11. Hope all of you are fine by the grace of Almighty. So let's start our session, boys. Today I will show you an creative question from chapter 11. Let us see the creative question first. A person tries to lift a particle of weight 375 Newton by a lever. Here, length of force arm is 1.5 meter and load arm is 0.5 meter. I think all of you know about length of force arm, load of arm and lever, as we have finished these things earlier. So let's see the question, boys. A. What is the unit of force? B. Why mechanical efficiency has no unit? Explain. C. Find the amount of force the person has to apply to lift the particle. And D. Analyze how much extra force should be applied than before to lift a particle of weight 525 Newton by the lever. Now boys, let us see the answers of the question. A. What is the unit of force? As we know, unit of force is Newton, and it is a compound unit because it is combination of two units. It's come from the unit of mass and weight, mass and gravitation. So that is called Newton. Number B, why mechanical efficiency has no unit? First of all, we have to know what is mechanical efficiency. Then we will define why it has no unit. Let us know about mechanical efficiency. Mechanical efficiency is a measurement by which effectiveness of machines can measure by entering amount of force, how much force we will get back. That ratio will say, and that ratio is known as mechanical efficiency. So in our sense, in our words, we can say mechanical efficiency is weight by applied force. That means how much weight and how much force we are applying. That ratio is mechanical efficiency. In our book, we have also seen that mechanical efficiency is also ratio of length of force arm and length of load arm. So we can write mechanical efficiency equals to weight divided applied force, and that is equals to length of force arm equals to length of load arm, because these two ratios are equal as their mechanical efficiency. And look here, weight is one kind of force and applied is also one kind of force. And if you think length of force arm and length of load arm, there is also same unit. So we can see that mechanical efficiency actually is ratio of two similar units, and if the similar units divide, then there shouldn't be any unit because one cancel another. That is why mechanical unit efficiency has no unit, because it is ratio of two same unit. Okay boys, so that is the answer of why mechanical efficiency has no unit. Now let us see the amount of force needed for the particle to lift. First of all, let us see what we have given. Weight of particle, that is 375 Newton, one kind of force. Length of load arm is 0.5 meter and length of force arm is 1.5 meter. Now we have found in previous question answer, mechanical efficiency equals to weight by applied force equals to length of force arm divided length of load arm. Now we have here weight, we have length of force arm, we have length of load arm. So we have to find out applied force. So we can just separate these two fractions. Weight of force arm, weight divided applied force equals to length of force arm by length of load arm, where weight is 375 Newton. Applied force we have to find out. Length of force arm is 1.5 meter and length of load arm equals to 0.5 meter. After putting the values, the fractions should be like this. Now as we have to find out the applied force, we can keep it one side and the equation will look like this. Applied force equals to 0.5 meter into 375 Newton divided 1.5 meter. Now, this 0.5 and 1.5 division makes 3, and that 3 divides 375 and it makes 125 Newton. So the applied force to lift the particle is 125 Newton. That is, applied force on lever for lifting the particle is 125 Newton. That is the answer of question number C. How much or what amount of force is needed to lift the particle. Now in D, we have to lift heavier particle than this one. The weight of the particle is given 525 Newton, and here length of load arm and length of force arm shouldn't be changed. So how much extra force we have to apply here, we have to find out. First of all, we have to find out what is the amount of force here needed to lift it. So similarly, from mechanical efficiency, we can write weight divided applied force equals to length of force arm equals to length of load arm. So weight is 525, length of force arm is 1.5, and length of load arm is 0.5. So if we put the values, the fraction will equation will look like this. 525 divided applied force equals to 1.5 divided 0.5. We need to find out applied force. So applied force is 0.5 meter into 525 Newton divided 1.5 meter. So 0.5 divides 1.5 makes 3. That means 3 times it divides 1.5, and that 3 divides 525 by 175. So applied force here is 175. So to lift the second particle, it is 175 Newton, and earlier in C we have got the answer how much amount of force we need to lift the first particle. To lift the first particle, we need 125 Newton. So here the difference makes the answer that how much extra force we need to lift the second particle, that is 175 minus 125 Newton, and it becomes 50 Newton. That is the answer that analyze how much extra force we need to lift the second particle than before or previous one. So boys, here I have showed how creative questions can come from this chapter. There can be different pattern also. So try at home to solve this. I think this should be beneficiary for you. In next class, we will do another CQ from another chapter from third term. Okay, boys. So that is all for today. I'm taking bye for today.